Well, all right, everybody. I think we're at a pretty good group here right now. A few more will probably trickle in as we get started. So let's go ahead and kick things off. Uh, I don't have much in the way of community announcements myself, other than to just try and keep us going virtually. I do have some open speaking slots coming up over the next several months. So if you would like to try your chops at speaking and sharing with the group, it'd be a fantastic opportunity for you. And just reach out to me, and we're always the last Monday of the month, even virtually, so I'll find a spot for you. But without much further ado, I'm going to turn this over to our good friend Jeremy, and he can wow us all with Blazor WebAssembly and EF Core.
Oh, I have to wow you? I can't just...
I think that was in the subtext of the invite. Yeah.
Oh,
wow.
okay.
It's required.
Yep. It's got to be as advertised then. All right, let me share my screen here. Let me know when it's coming through. I know sometimes the bits can be a little slow to travel.
They have made it to Atlanta.
I see it.
Awesome. Yeah. Great. All right, well, without further ado, this is our topic, EF Core from Blazor WebAssembly. I'm Jeremy Likness, formerly from Atlanta. I even the Atlanta backdrop for the sake of this meeting from the last time I was down there back in the day when we used to travel and go places. But I am now located near the Microsoft mothership in Redmond and enjoying a 45-degree high today. Fall's coming pretty quickly here. But let's talk about the plan for today. So there's a why, an experiment, and a result. What I want to talk about is a project I've been working on. I recently took over a role as program manager for .NET Data at Microsoft. I'm concerned with the data experience. And a big part of that experience is Entity Framework Core. It's our data access API, object, parentheses, relational mapper. I say in parentheses because we also have a adapter for Azure Cosmos DB, which is not relational. So it does provide an API to that as well. But one of the newer technologies that I've been doing a lot with is Blazor. And feel free to share if you have questions or comments or whatever as we go. This is a very informal presentation. You're not going to throw me off my rhythm or anything if you have questions. I am curious who is using Entity Framework Core. So if you feel like throwing that into the chat, that would be great to see if anyone's using that in their projects. But basically, the new technology I've been doing a lot with is Blazor. And Blazor's a pretty exciting technology. If you're not familiar, I'm actually wearing one of my Blazor shirts from a previous conference of breaking free from JavaScript. And it gives you the ability to build single-page applications using C#, F#, basically .NET, and run those in the browser. There are two flavors of Blazor. There is a server flavor, which basically does everything on the server and uses a SignalR connection to send fragments of HTML to the client. And then when events happen on the client, they're sent to the server. Server does the work. It's a great programming model for developers because you can connect to anything that you would ordinarily connect to on the server. You can store secrets. You can do all of that, and it's just a very lightweight client. The problem with Blazor Server is twofold. One is if you're looking to build a progressive web app and you want offline, that's not supported. It needs to maintain a connection. The other issue is when you're using it at scale, all of the work is done by the server. So if you have 10,000 concurrent users, you have 10,000 concurrent workloads all being put on the server, as opposed to a traditional web model where a lot of the UI is happening on the client and it's distributed, and the server is just doing the heavy lifting like talking to the database backend. So that takes us to the challenge that I think a lot of people run into. when you're dealing with the client, which cannot connect directly to SQL Server because it's inside the browser sandbox, you have to find a way to bridge the gap to the server. There's a lot of technology to do this. You can use a REST API endpoint. You can use WCF. There's actually an open source project that will take WCF to Blazor if you so desire. You could use OData. There's a few different options, but what I found traditionally is the create, update, and delete, the CUD part of CRUD, is usually pretty straightforward. We know how to post an entity, perform an update, read that entity back. What gets complicated is when you're filtering and sorting and querying data. And there's different approaches to that. There's certainly valid approaches of having some sort of metadata object that contains all the possible permutations. But one of my favorite technologies to work with is LINQ. LINQ is very expressive. LINQ is a great way to define a query. And my thought was, when I joined the team, how can we allow you to use LINQ in the WebAssembly client and transmit that to the server, so that as a developer, I'm not worried about building these extra APIs. I just want to write LINQ and go to work. So that was the thought process, and I'm going to dig into some more details. So on the why, I'm going to talk about why I picked EF Core as a technology, language integrated query, what's important about iQueryable. I'm going to dig into the experiment and the phases I had to go through to get to where we're at today, and show you a little bit of the result as well as answer your questions and answers. So hopefully you find it as interesting as I found it to be. It's been a learning process for me. It had been a while since I worked with LINQ and expressions, and I had never done a deep dive into iQueryable. And all of those things were pretty amazing technology journeys, and I've learned a lot. So this is the plan. We're going to go through it right now, and we're going to start with the why. And it's because what we do in code echoes into eternity. No, seriously, the why I explained that, I like making life easier for developers, and I've had a philosophy of working backwards. In other words, I like to start with the experience I think is ideal, and then working backwards to figure out what elements need to go into place to support it and make it happen. That's how I deal with APIs, fluent interfaces, everything along the way. So the first thing I want to show you is live, sort of what that end experience I believe could look like. This is live. I'm going to do file new. What could possibly go wrong, right? We're going to dive into this and see what we can make happen. So here I've got should be familiar Visual Studio dialog to create a new project. I'm going to create a Blazor app. So let's go ahead and click next. And it's asking for a name. I'm going to actually throw this away after I build it, so I'm going to throw it in temp. I'm just going to keep the default Blazor app 2. I'm not looking to build an app. I just want to demonstrate a point. Notice that we have these two options. We've got Blazor Server app and we've got Blazor WebAssembly app. The server app is the one uses the SignalR connection. WebAssembly is the one that runs in your browser using an amazing technology called WebAssembly, which is essentially like a virtual machine that can run code without having to use plugins. So it's plugin free. We're going to do an ASP.NET Core hosted and click create. And this will spin up a brand new Blazor project that has a template, navigation, basically has a simple structure that you can use to get started. And of course, it'll pop open on the screen that is not sharing. So everything else here happens in the dark. Just kidding. Let's bring this over here. So the first thing I'm going to do is add one library. There's only one pre-baked thing I'm doing in this demo because I didn't think you'd want to watch me set up the actual data store. So I'm going to add an existing project to the solution. We're going to go to ctemp. And I've got this data lib that I predefined, so let me add that project. And the data lib is pretty simple. I've got a class called something because I wanted to show you something at the start of the talk. It's got an ID, a name, an active count, basically just some fields so that I can query on the fields. I have a create things, and in the create things, I'm basically cheating a little bit and getting the types out of the app domain. I'm using reflection and using those to populate the names of the things. And then I'm just generating some random, if it's active or not, what the count is the count of the members on the type. It's just a way to get data into the database. Then I've got this thing context. If you're not familiar with Entity Framework Core, a data context is your host for the API, basically. It's how you define the relationship between C# code and the database. Because what Entity Framework Core strives to do is allow you to use .NET languages like C#, F# to talk to your domain model and abstract away all the nuances of how that gets persisted to the database. In real life, it's not as simple as that ever, but it can come pretty close. So this DB set is how I expose the equivalent of a table. So it's a bunch of things that are made of something. And then I added this check and seed method, which basically just looks, and if the database isn't created yet, it creates it and adds some items to it. So pretty straightforward. Normally, you'd either have an existing database or you would use something called migrations to set up your database. I'm trying to keep this simple. So that's the one pre-baked thing. In my shared Blazor app, you'll see there's 3 projects that came out of the box. There's the client, there's the server, and there's the shared. And those are exactly what they mean. The server is the server-side ASP.NET Core host that hosts your server-side logic. The client is what, runs in your browser. And then shared is shared between the server and the client. So I want to actually share this database between both of them. And I'll show you why in a second. So I'm just going to go to the shared project and add a reference there. And that'll automatically make it available to both the client and the server. So we're going to just take the data lib here, click OK, and now it's shared. So now we have a reference to it for the server. So now I'm going to add a few NuGet packages. So let's go to our NuGet package manager and let that open. I'm going to take off pre-release for the first step. And to make this again simple, I'm going to use SQLite. And there's really 2 reasons I'm going to use SQLite. One is because it's cross-platform. So if you use SQLite in a demo, if someone happens to be on Linux, they can run it. Whereas if I use SQL Server and they don't have a SQL Server, local SQL, the local DB, is only available on Windows machines. So I like SQLite. Second is it's just such low overhead. Everything you need is included in the package. I don't have to install SQLite to use it. It comes as part of that NuGet package. It's not a separate install. So what we're going to search for is Microsoft Entity Framework Core SQLite. And we've got the package there, and I'm going to add that to the server because that's what's going to host it. And just imagine this could easily be talking to a SQL Server or some other database. So we'll install that, click OK, I accept. And we're installed there, no errors, no warnings, we're good to go so far. The other thing I'm going to do is add some pre-release packages. And no, I don't want the toolbox open. Let's close that out. It's always nice when you get a spinner when you weren't expecting a spinner. Let's do expression power tools. And we've got 2 libraries here that I'm interested in. One is an ASP.NET Core middleware. So something I love about ASP.NET Core is the ability to extend through middleware and make it pretty easy to add new features and functionality, and I'll show you what I mean by that. So that's going to the server, ASP.NET Core, so we'll install that and click OK, sign our life away, I accept. And then the next thing we're going to do is this HTTP client is going on the client. So we're going to highlight this, make sure the client's checked, and install it. So far I've created a new project. I've added a library that models my database, and I've added some NuGet packages. Now we can actually write some code. The first thing I'm going to do code-wise is go to my server, go into startup, and I'm going to configure a couple things. Here where we're adding services, I want to add my database context. So I'm going to do services, add DB context. I give it the type of the context, which is a thing context. That's the class I defined. And then the trick is control period will give me the using statement. And then the only other thing I want to do is this gives me an option to configure options for the database. So a strategy that's fairly common is to have a generic data context that you use and share between projects. Then you have an implementation of it. In test, the implementation might be SQLite. In production, it might be SQL Server. Now, there are differences between databases, so you have to be aware of those. But this is a very simple model, so I could probably spin it up with any of the major relational databases with no problem. So I'm just going to tell it to use SQLite. And the connection string for SQLite is actually the file name that you want to store it to. You can obviously do other things, but this pretty much says, okay, let's have a API available for the database, and we're using SQLite and we're storing it in this things.db. The other thing is down here, now that we've got our services configured, I want to go ahead and seed that database. This is the step you normally would not do in a production application because you'd be managing the data separately or through migrations. But because this is a demo project at startup, I just want to check, is the database there or not? If it's not, create it, load it with data, make it easy. So I'm going to take this application builder, take its services, and then you need to do something called create a scope if you're doing it here because it hasn't scoped the services. And the scope really refers to if you want something as a singleton that's available to all users across the application, single copy, if it's a new one per user, etc. We're just creating a generic scope so that we have something to get our service provider from so that we can get our thing context service. Seems like a lot of work, but this is just a step to grab what we just put into dependency injection. So I'm going to say using context equals like that, and then I'm going to call context, and what was that called? Seed, check and seed. So that's the step to create the database and add data to it. I'm only going to do one more thing on the server. I'm going to come in here where we're mapping endpoints, and I'm going to say endpoints, add, and I'm not getting my IntelliSense, so that means I need to come up here and add a using. So we'll do using expression power tools, serialization, EF core, ASP.NET Core extensions. Then we'll come back down, and it's actually map. That's why I wasn't seeing it. So map power tools. Now this is an extension method in the ASP.NET Core middleware. And all I'm telling it is I want you to automatically expose a way for me to talk to this data context using this tool I'm going to share. So the data context we're going to use is thing context. So that's the only step with the tool that I built to configure it to get ready to listen. Now there are other options that you can use, and we'll explore some of those. You can change the pattern for what the endpoint looks like, add some rules and things like that. But for now, let's just stick with that. And then let's pop up to the client. So the client actually builds its services up here in program.cs. I'm going to do the same thing, add my using statement. Serialization, EF core, HTTP extensions. So that's for the client. And all the client needs to know is what is the base address of the server that it's talking to. So I'm going to borrow this. And just so you know, what this is adding is a default HTTP client that's ready to talk to the server. So it's giving it the server's base URL. And if you use dependency injection to inject an HTTP client, you can just use relative paths in your code because it's already configured with the base address, which makes your code more scalable because if you have a different host environment base address, it just automatically updates. We're creating our own client. So what we need to do is not navigate to the metadata for that, but we'll use our extension method. So we'll do services, add expression power tools, EF core, and what it's expecting is that base address. Now I've done all the configuration. We're going to test to see if it builds because we all know that as long as it builds, it's ready to ship. Of course, it doesn't seem like it'll do anything interesting yet. And if that's what you're guessing, you would be correct because we need to go beyond just configuring what we're doing and query the database. So here's the piece that I was working on. So I'm in the client application, which is inside the browser, and I want to take over this index page and actually do something with that data context. So I'm going to add a couple using statements to make my life easier. Going to do expression power tools, serialization, EF core, HTTP, Queryable here. And we're going to do a using for that shared client. So it's Blazor app2 shared. Actually, is datalib by itself? Yeah, using datalib. Okay. So the way that you do code in Blazor, if you're not familiar with it, you can have a separate code behind file. I'm going to keep this a little simple and just expose some code here inside this code block. And what I'm exposing is a list of something called things. And I'll initially set it to null. Now in my UI, I can add a little bit of logic. I can say basically if things not equal to null, then I'm going to start an unordered list. And then I'm going to say for each thing in things, we're going to do a list item. Not sure if you're aware of this key, but this will actually help optimize how it's rendered. And then we're going to do, let's do strong at thing dot name. And what else can we put? We'll do account. We'll do is active. And I believe I put a date on there as well. So we'll do the date. So this is just a list that's showing items off of it. So ordinarily what you would do here is you would go out to an HTTP client, do a fetch, deserialize some JSON, pass a query over. Let me show you a different way to do that. Let's override on initialized async. Let's turn this into an actual async. So this return turns into an await. And then let's do this. Let's do, nope, not an exception. Things equals await. And then I'm going to use this thing called a DB client context. So DB context is what we defined on the server. I'm going to do a DB client context for the thing context. I'm telling it I want to do a query, and it's asking me which collection are you interested in. So the collection I'm interested in is the things collection. Then I can do, let's say, where TT count is greater than 5. Order by T, let's order by active. So we'll have inactive and active together, then by created. And I want to execute this remote. Which it's not showing up, so that means I need to come grab my extensions here. There we go, now it lit up as list async. Okay. Wait, is it as list or is it to list? To list async. There we go. So this is it. This is a couple steps of adding a package, configuring the data context, and then I'm writing a query here. Now this is not the way I'd recommend you do it, and I'm going to talk more about it. But the important thing is, will this actually even run? Let's go ahead and start without debugging and see what we can see. All right, we're getting close. We compiled without errors. Let me drag this over here. And dun, dun, dun. Boom. There we go. So there's the data. It looks like we've got false coming first. We've got date order here, 9/2, 9/10, 9/13, 9/19. And we've got the types that it grabbed. So that is the vision. The rest of what I want to talk about is how to take that to the next level and actually how I got there. Before I do that, that's interesting. It doesn't want to, there we go. We'll close this out. Let me just double check on chat here, see if there's any questions from what you've seen so far. Does this support join semantics? That is a great question, Jim. Now, if you have a navigation property, then you can join, but right now its root is a collection, so it doesn't support joins across collections. If you can navigate to, like you have a thing and a sub thing, and I'll show some of that, but that is something that if it's important enough, which it probably is, we will explore. Okay, let's come back here. All right, so I'm actually happy that it compiled and ran, and there was a question, can this work with an Azure function? So the answer is maybe. So I'll get into how it works, and then we can talk about how it would probably work with a function. So that's a great question, and I think it could with some proper mapping. The only key here is how the routes are mapped, and then how it accesses that. So the first thing I'm going to cover is why I use Entity Framework Core. Now, some people love Entity Framework Core, some people hate Entity Framework Core, some people don't care and don't even know what it is. But if you look at the actual data, 3 out of 4 projects, actually 3 out of 4 users who are using any project referencing SQL Server use EF Core. Now, those numbers may be a little bit higher because of Identity Server. So if you use Identity, it by default creates a SQL Server and accounts and uses that as the backend. But even if you look at other providers besides SQL Server, there's very heavy usage. 30 times users on projects using EF Core compared to GraphQL, for example, although it's a little bit apples to oranges because you can obviously use GraphQL with EF Core. But just if you've heard a lot of hype around GraphQL, just know that this is something that has a much broader footprint. And the next most popular ORM is about half the usage of EF Core. And so my point here is not to convince anyone to go to EF Core, but to say that there's a huge footprint, a large number of developers using it. So making developers' lives easier with EF Core is something that is a priority. Why language integrated query? I'd be interested if you want to put it in the chat what people's thoughts about LINQ are. I personally love LINQ. I think it's amazing. Your mileage may vary, but with LINQ and with something like Entity Framework Core, instead of doing the things the way we would ordinarily do them, which is with select statements or stored procedures and adding parameters and shaping it and going to a client or an adapter, this to me is much cleaner. Having a strongly typed query with some Lambda expressions to express what's happening. That's LINQ, but LINQ will actually work with any type of enumerable source. So we can use expressions, we can use LINQ extensions without ever touching iQueryable. iQueryable, in my opinion, is where the magic really happens. So iQueryable is strongly typed. It's declarative, but you have multiple options to choose from. You can use the method syntax, which is the one I prefer. Excuse me, but there's also I forgot what the syntax is like. If someone can tell me, there's a name for it where you're actually just typing loose, joined by, etc., not using methods, but using more, it looks like SQL syntax. So there's an alternate syntax there. It's extremely flexible. So Jim Woolley says he calls that query syntax, which makes sense to me. It's extensible, it's testable, and it's backed by a provider. The provider is the real key to how this all works, and we're going to dig into it in a little bit. But conceptually speaking, when you build up a query using iQueryable, you're defining a template. You're not actually doing anything. When I did the where clause, when I used the order by, I was building up a expression tree that represented an idea of how to shape my data. It wasn't until I called toList or count or single, until I started getting data back, that it actually did something. You can create a list of items and run LINQ against it, and you'll use a built-in feature called LINQ to Objects, which is a provider that knows how to scan through enumerable objects and apply the patterns and pull out the results. When you use something like Entity Framework Core, it takes that same template, so there's no change on my end, I'm still writing it the same way, but it walks through that expression tree and translates it to SQL or Azure Cosmos DB SDK commands and does what's needed to pass that on to the database. And you'll see some examples here that make it very evident that we're not going out and fetching a bunch of items from the database and then filtering them. We're actually sending the filter to the database because the database does the best job of doing that in most cases. So if you're not familiar with the iQueryable pattern, I find a lot of people are familiar with the repository pattern. And that pattern, you would define something like get a list of items, get a single item, update, delete, and you're abstracting the implementation details. I love using the repository pattern in Blazor projects. And here's why. Sometimes people decide to switch between Blazor WebAssembly and Blazor Server. WebAssembly can't talk directly to SQL. Server can. If you use the repository pattern, you can write code that talks to the same interface. You can use a Razor class library, have that index page I showed you, talk to the repository, say, give me a list of items. And on the server, you can implement that interface with Entity Framework Core or even direct calls to the database. On the client, you can swap out an implementation that uses HTTP client to talk to the server, and the code is exactly the same. So it gives you flexibility. But for the query part of it, I like to expose something like this. This interface exposes iQueryable. Notice that there's a root get the base query. The base query is important in some cases because in one case I might be looking at a data context, and that's where I start my query from. In another case, I might just be using objects, and that's where I start it. So I want my view model or my service or my page to be able to get the base query to start building on. And then once it adds filters and sorts and everything else, it can pass that query into something like, give me a count of items that match this query, give me a list of items, or even something like the last one, which is using an implicitly named tuple that says, give me the count and the query at the same time. So this is an example of an implementation. This would be the implementation for the WebAssembly client using the DB client context. So the base query starts with that context. Get count just executes remote, count async to list async, and then I've got one that does them both in a single call. However, for testing, I can do this. I can implement that same interface, add some other attributes to help me out with testing, like be able to inspect the last query, see how many times get base query was called. And then I'm able to do a test like this. This is a MVVM application I'm working on as a reference application, and we're telling the view model to go to page 3, waiting for it to load. And what we're actually concerned about is that it does the correct math, that when we set the page to 3, that it's going to take the page size and skip over 2 pages. So in this case, the page size is 20, so we're looking for this skip 40. So it's a test that the view model behaves the way it's supposed to without having to involve the database. This is a completely in-memory test. So that's why I'm a fan of iQueryable. So this is the experiment. You saw the package that I installed, Expression Power Tools. Feel free to check it out. And this, I call it the experiment because this isn't me setting out to create a new product. It really started out for me to learn expressions and iQueryable inside and out, as well as to get a lot more deeply familiar with EF Core. I started this when I joined the team and felt it would be a good project. Along the way, I ended up building my own custom documentation generator. So it basically uses all my XML comments and creates Markdown in GitHub. So when you browse the API documentation on GitHub, and I'll just show you that really quickly. But I want to talk about the components that went into doing this as well. This is probably just fun because I could have used DocFX or some of the other tools out there. But as engineers, isn't it fun just to reinvent the wheel and build things ourselves? If we go to the documentation, so this is some stuff I wrote, but if I look at API documentation and then I look at HTTP, what you're going to see is a list of namespaces, and you're going to see it was generated here and a version number. So if we go into Queryable, we're going to see here's our different classes, here's a DB client context. All of this is just auto-generated from XML docs, and the project is part of this. If you go into the source, you can see that there is it's under Tools. There's a tool to generate documents. This also automatically parses test results and some other things. So the second thing that I wanted to do with this experiment is really see what it takes going from scratch to build a repo that has all the features you'd expect from a full-fledged repo. So automated builds, automated document generation, automated test runs, automated NuGet packaging, semantic versioning control. So all those pieces were part of the process for this. But the very first thing that I found I needed to do is be able to enumerate the expression tree. And I wanted a way to do it that was more flexible than what comes out of the box. So if you're familiar with expressions at all, there's something called an expression visitor. And I'm curious if anyone's actually had to deal with expression visitor in chat. I see some vibrant conversation going on. But an expression visitor is a base class. I'm going to show you an example of that automatically recurses through an expression tree. And it gives you methods to overload. I wanted a quick way to be able to list out the parts of the expression tree so that I could do things like pull out information or verify that a member was there. So the very first part of this was actually figuring out how to enumerate it. And I want to show you an example. Let's see. Do I no longer have a command line? I don't. We'll fire this up. I want to show you another trick too. If you're doing experiments with code and you want something interactive to do them with, there is an extension for Visual Studio Code Insiders called .NET Interactive. You may have heard of .NET Interactive. Our docs have little snippets that you can run C# inside of the browser. That uses the .NET Interactive engine, but it's basically an interactive way to work with .NET code. So what you can do is I'm just going to make a directory called ATL Pres and go into that directory. And then I'm going to create an empty file called livecoding.dib. DIB stands for .NET Interactive Book. It's basically a notebook. If you've heard this concept of notebooks, it's exactly what we're doing. So we've got livecoding.db. I'm just going to open Code Insiders in the current directory. And we can see everything is happening blazingly fast. Actually opened in another window. That's fine. Here we go. So I'm going to open this livecoding.dib. Now, because I have the .NET Interactive extension installed, it automatically detects that this is a .NET Interactive book, and it's spinning up the .NET Interactive engine. Now it's ready for me to write code. So what I can do is add some code. Let's define a class, public class thing. You can see I'm always very creative in my naming. So we'll give it a ID, we'll give it a active, we'll give it a name, we'll give it a date. Let's do date time created. It's set. And then let's go ahead and override toString. I missed my control dot. Actually, I'll leave it like this for now. But let's do this. Now, if I play this, yes, I can make that font size bigger. How's that? should be good. If it's not, let me know, but I'm going to run out of space pretty quickly. So if I run this, all it's doing is basically processing what's inside of that cell, and it knows that I have a class thing. So now what I can do is, let's do a using system link expressions, and let's create an expression. So the expression I want to create is going to be a function that takes an integer for the ID and returns a thing. So that's the signature of the expression. We'll call it make thing, and we'll tell it to take the ID and return a new thing with that ID set. So that's an expression. If you're not familiar with expressions, I can't do this. Make thing one's not going to work because this is an expression. It's just a template for the thing. What I can do is I can write the expressions to string and show you how the expression actually reveals itself, which is pretty straightforward. It's ID equals new thing. That's pretty much the code that I wrote. But this is not a single expression. This is an expression tree. There's actually more to it. In fact, let's do this. Let's create a new cell, and I'll show you part of what the first step that I needed to take was. R is how you do a reference in .NET Interactive. We're going to get this from NuGet, and I'm going to do expressionpowertools.core, and I'm going to do the latest version, which is 9.7 beta, and then I'm going to do a using. Well, actually, I'll wait to do the using. Let's just activate this cell. So what this will do is in the .NET Interactive engine, it'll install that NuGet package for me. Okay, now that's installed. So now we can use core, we'll do extensions. And then what I'm going to do is expression tree equals make thing as enumerable. So what this does, this is an extension method that'll iterate the tree. I know there's red squigglies, but I'm pretty sure when I press play, those will go away because it hasn't processed the using yet. But what this will do is it'll unroll the expression tree and visit all the nodes recursively and turn it into an enumerable list. That enumerable list also has an override to print out a string. So I'm going to do a console write line expression tree to string. Let's run this and see if we got it working. And there's our expression tree. So what we've got is we've got a new expression that's creating a new thing. Then we have what's called a member initialization expression. That's what's setting the ID. We've got a parameter. That's what brings the value in for the ID. And then we have a lambda function. The lambda function is what actually turns this expression tree into something usable that we can interact with. So that's the expression. Then what I can do is some interesting things. Like, for example, let's say I wanted to understand the constructor for new thing. Well, what I can do is constructor is make thing as enumerable. Then I can say of type new expression. And let's use some link and say first or default. And then let's do a console write line CTOR. So it's a new thing CTOR. CTOR actually has a constructor parameter which is the actual type constructor. So what I can do is say declaring type here, and if I run that, we should get thing back. So now we're just able to do some interesting things with it. So it makes it easier for me to work with the expression tree. So that was the first thing I had to build. Next thing is comparing. If I'm going to successfully move a query from the client to the server, I need to know that it's going to run identically as if it were actually written at the server. So I need to be able to compare expressions. And I'm pretty sure if we do something like this, let's go up to make thing here. This will be funny if this actually turns out to true. I actually haven't tested it this way yet, but let's add code. Let's do make thing 2. And then let's write so it's false. It does the exact same thing. So for me, for running a link query, these are identical, but for the purposes of equality built into the .NET type system, they're not. So what I did is I created an extension method called makeThing is equivalent to makeThing2. If we run that, you can see that that's true. Now let's just create a third one and we'll change the expression slightly. And we're just going to make a new thing and not set the ID. So it's basically just throwing the ID away. Now if we do console write line make thing is equivalent to make thing 3. So this will be the third comparison that we see. You can see that it's false. So what this comparison actually does is recursively goes through each tree and looks at each section, and then there's a set of rules. In fact, in the source code, let me see if I have this. In the source code, you can see what the different rules are based on expression type. So if I go into core comparisons, default comparison rules, and this is where I again emphasize this is a fun project. I wrote these rules out in code, and then I realized I could use expressions to express the rules themselves. So these are rules expressed in expressions. So for example, for a constant expression, you've got the source type must be similar. Well, this is similarity. So there's similarities and equivalencies, and I'll talk about that in a second. But the default rules must be the same type. If one value is null, the other value must be null, otherwise it's false. If it's an expression, it recursively compares the expression. Otherwise, there's a helper method for values that are equivalent. So it's basically a library for comparisons. The reason why I have equivalency and similarity is because I wanted to be able to do something a little bit more, and that's actually dig into some details of queries. And what do I mean by that? Well, let's make a query off of our thing. So what we can do is we can say query equals new, and I just do a list of thing. It's an empty list, but if I do as queryable, then I have a query that I can start with. And I can say, for example, query equals query where TID is greater than 2, and order by TT name, skip to take 5. So that's a query, and I can do a console write line string, and it's pretty much going to give me back a syntax similar to the way I explained it. It's giving me the full type for a list, It's a thing where TID greater than 2, order by, skip 2, take 5. Now, one of the things I'd like to be able to do is, if I'm going to open up this possibility for writing queries on the server, I don't want to open the world to just any type of query. I want to be able to put some rules on it. So I might want to look at, are you actually limiting your takes? Is take part of this query? Let's look at the query tree for a second, and I'll show you what that looks like. So I'm going to say query as enumerable. This should be as enumerable expression. So this is enumerating the query to string. So this should give me the expression tree behind this query. Let's see. So here it is. You can see there's these method call expressions. There's these constants. There's a unitary expression, type parameter. There's a lot that goes into building this tree. All I really want to do is be able to say this. Console write line query has fragment Q skip 2. That's going to check that they actually applied a skip to the query. I'm going to do skip 2 and skip 3. If you remember up here, we defined it as skip 2. So this is going to test that. And you can see it has the fragment skip 2 or false. So that helps me with testing, but that has to be a similarity because the expressions aren't entirely identical, but I'm finding an expression that's a skip with a value. So that was the second piece, was making these comparisons and being able to test our results. The next part was actually very interesting, and this was something I hadn't anticipated because I kept testing it with queries like if ID is greater than 2, if isActive is equal to false, but there's a problem, and I'm going to go to another project to show you that. And Ken, are we shooting for, what is it, 8 o'clock, so 8:30 to wrap up? Is that about right?
Yeah, 8:30 is good.
I don't want to go super long, so I can move through some of these, but let's open recent and go into simple Blazor WASM. So this is a sample that's part of Expression Power Tools. And I'm just going to go and move my mouse clockwise to speed up the loading process. Okay. And let's start this one without debugging. Dear, 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 dear. Okay. What this project does is it gives you a peek behind the scenes of what's going on with these. I'm going to basically tell it to filter on true. We'll order ascending. We'll say created greater than a week ago. And you can see it's immediately bringing up the results. If we look at my server, I've got logging turned on. So the server is showing me the SQL query, which you can see is filtering in SQL. This is the expression that's coming across the wire. What this tool allows you to do is look at the query snapshot. And if I look at this query, this is looking at the query tree for the basic query. What you can see is this T is active, and let me zoom in for you. This T is active is looking at this variable is active. And then it's saying basically property created, it's got this convert of this value to an int to 1 to 7 to 14. So it's basically referencing all these variables to get the reference to the date, to the isActive, etc. The problem is if I send that over to the server doesn't have an isActive variable. The server is just expecting a value. So the compression phase basically walks through the query and finds the pieces that can be evaluated immediately. I can evaluate some of the things because they require looking at the database, but I can figure out, for example, this variable is active can be evaluated to the value that I've actually picked up here, which is true. So if I look at the compiled query, you can see it's much simpler. Is active equals true. It's resolved the date range, and that's what's actually getting sent across the wire from this fun little query tree that comes out of it. So that was the compression step, and the compression step is interesting. I'm not going to go through all of the code if you want to check it out, but let me just highlight a couple bits of that. If we look at this and we go into source, serialization, compression, there's a few different pieces. And I said I would talk about expression visitors. So there's this expression nominator that derives from expression visitor. The expression visitor will automatically iterate through all the nodes of a tree for me, so I don't have to do anything special for that. And I needed to use this instead of the enumeration because I needed context of parent and child. So instead of a linear look through it, I actually needed to know I'm a child of another child, because what this does is basically 3 passes. The first pass looks to see if anything has a parameter. A parameter is something that would be supplied from the database. The object from the database is a parameter that gets evaluated. So if something's looking for, like, is active on the thing type, I'm not going to do anything with that because that needs to get passed to the database. If it doesn't have a parameter, it's a candidate to be compressed. So that's what the first step does. The second step actually evaluates those nodes. So it'll take that is active variable, evaluate it to the value which is true, and turn it into the constant true. So instead of passing a variable, I'm just passing the constant true. The last thing it does is some logic. For example, you may end up with a node that says and true equals false, because true was the condition, false was the variable. Well, that's obviously false, so that can be collapsed up. So there's some logic there to collapse that down. That's what the compression piece does. It makes it more compact to pass over the wire, but also evaluates the various variables that are part of it. The next piece of it is serializing. Serializing was interesting. I went down 2 paths for serializing. The first path was tied directly to the JSON serializer. That's the way you can see the JSON that's actually reported by the server. But I realized that I may want to do things like gRPC or other protocols. So the way that the serialization works is it converts from the expressions, which are not directly serializable, into these special versions that are serializable. So for example, for a constructor, the important things on a constructor are the actual member, and the member is the type in the .NET runtime that represents a constructor and all its parameters. So we want a string that represents what that type and its value is. And then we also want a set of arguments. These are the parameters that we pass in. So if you have a constructor that takes an integer and a string, we would have expressions that represent an integer and a string. You also have these things called member keys. This is how you do initialization. Arguments get passed to the constructor, but then you might have your brace and say ID equals 1 or ID equals 2. That's where the member keys come in. So all of this is serializable. So it creates a serializable tree, and then there's a separate adapter that goes through that tree and serializes it. And in this case, I ship it with a JSON serializer. And last and probably most important, when we were talking about this as a team, the ability to write queries on the client, obviously security comes into play. And if you haven't thought about it yet, I could potentially write a query that basically, as part of the query, selects a news up a object that might be a system object that exposes file system details. And then as part of the query, actually call a method that deletes a file system, for example. So those are things you don't want to happen. So the way that I built the security system was a opt-in security. In other words, you can't new and you can't call any type of member unless you explicitly configure it as a rule. And the easiest way to see that in play is there is a comprehensive set of tests that come with this. And it's probably the easiest way to learn the API as well. But if I go into the tests and I look at the serialization tests, there should be some rules tests. Let's see, rules engine tests. And so you can see I've defined a bunch of classes and properties and other things. I also have generic types and closed types, etc. And the test is just calling this member as allowed and getting the result. So here we're just seeing, do we have access to it? We also have a setting for anonymous types. The nice thing about anonymous types is you can't actually build methods or members onto anonymous types, so they're just data. Let me see if I can see one. So here's an example where we're explicitly grabbing a member and denying access. That's how we're configuring the security. Here's one that's a deny. Here's one that's actually allowing it. And the way the rules engine works, so you don't have to write a ton of code, is it's basically hierarchical. So if I allow access to the generic type, it automatically allows access to a closed type, but you can explicitly opt out of that too. So that was a lot of fun putting that together. What I'm working on now, before we actually come out of beta, is tying into the authorization pipeline. So I could come into this app, into the source code, and where I'm configuring the server right here, go up to where it adds. So right here, so notice that I have this rule for type group thing and rule for type related thing. That's because I'm demonstrating a group by here, so I can do a group, and this will do a group by query, and I have a select many. This does multiple projections and then maps them back together into a massive result set. So it's basically showing you how to use anonymous types and projections and some other things. But in order to enable me to new that up, I need to allow it as a rule. And what we're working on right now is to add this last rule, which is auth. And you can say something like, must be authenticated to query any collection, or to query a specific collection, or to query a DB context. And I'm also going to add a callback so that if you have roles and permissions. But this was the really last critical piece, was being able to implement security so that it's not an open-ended API. And you can do things like tap in and suppress how many records are returned, etc. So let's come here. So putting it all together, I'm going to show you two things and then we'll wrap up with Q&A. The first is the project that I'm in right now. I want to show you how the queries are related. I actually put the queries in this shared project here. And the remote query service follows that pattern I talked about, where it basically implements an interface that exposes queryable options. And you can see I've got some enumerations. I've got actually I didn't implement the interface here, but it's derived in the client. So it's got some values on it. So think of this as a view model, but it's Blazor style. Blazor doesn't require property change notification, so you can just expose the properties. And the interesting thing, there's a name filter that's making sure it's just alphanumeric to avoid any type of crazy strings coming in. We've got this overridable root query. So by default, we're just doing this off a list, but in the client, it'll use that client DB context. And then we have a few methods that piece the query together. So for example, here's the group by. So it's grabbing the basic query, then doing the group by select, new group thing, order by group name, and returning that. This is the select many. So this is showing projection. See, I'm using anonymous types here. And then I'm tying them back together into this single type that we order by. Then we've got the build query, which is basically just putting the pieces of the query together. Is there an active filter? Is there a name filter? Is there a created filter? So here is active. It's as simple as this. Here's our order by. So using the new switch operator and ordering by TID or TCreated or TValue. There's a descending if we're going the other way. There's the skip and the take. So all of these can be pieced together, tested, and then sent down. The other demo I wanted to show you is one that I'm working. So this will be released along with the authentication piece. And that is a view model example. And I'm going to give this caveat. I do not recommend that you use MVVM for Blazor. It's overkill. Blazor does not need it because Blazor automatically does its property change detection. However, many of the clients that I talk to who are moving to Blazor are migrating existing desktop applications that use MVVM to Blazor. So I wanted to provide an example that implements the MVVM pattern and shows how you can plug MVVM into Blazor the right way, because there's a lot of wrong ways. And essentially, if you're looking at a solution that hooks into property change notification and calls state has changed, it's probably not the right way to do it. You're adding a lot of overhead that's not needed. So this reference implementation shows how to piece together queries, but this basically gives us a contact grid. We can change the page size, so I'm going to change it to 10 here. We can page through, I can do next page like this, and then it does a double sort. So I'm sorting by last name, and then my secondary sort is first name. I can use the minus to take off the secondary sort, and then I get a plus over here so I can add it. And all of these are using view models and view model commands. If we look at the implementation, let's look at shared. So I've got this, which actually looks like what I showed on the slide, right? So it's an interface for the queries. And then there's an implementation of that. I've got a test project that uses a test host that just uses objects. And there's some fun things in here too, because it's an asynchronous refresh. So if you've ever wanted to test asynchronous code, there's an example in here. Let me see if I can show it to you, that allows you to delay something until you want the task to complete. So it uses this task completion source and captures it. And then when you tell it to switch it open, it basically completes the task. So you can press pause for testing purposes, look at some values, and then let it fire and continue. So that was a little fun. And then on the, I wanted to show the implementation on the client. So here's the implementation of the contacts query. And it's basically going to DB client context to get the base. It's using count async to get the number of records. It's using to list async. And then the view model is what's supplying the actual queryable. if we look at our view models, we've got, for example, a filtering view model. Actually, let me show you the paging view model. So the paging view model holds the page items, and it's really just capturing pages and raising events. In the contacts view model, this is listening to those events, and as it changes, see, it's listening to the pager, the sorter, etc. As these events change, let me see if I can get to the part where it's actually building. So it's applying a sort, applying a filter, applying the skip and the take, and then it calls out to that query source and gets the contacts with the count and updates everything here. So that's just an example reference application, and it again uses SQLite. So regardless of what else you have installed on your system, if you can pull down the project and build it, when you run it, it'll create a SQLite database and it'll run through that. So having said all of that, this is my blog where I have several series on expressions and expression trees, and Queryable. I tried to document as much of my journey as I could. This is the repo. That's my Twitter. I have open DMs. Feel free to reach out. And we've got a little bit of time, so if you have questions, feedback, comments, let me know. And then I also want to announce something in a second, but I want to address your questions first. Any questions or comments? Does anyone think it's just an insanely crazy, outlandish idea to even want to write queries from the client? All right, everyone.
Apparently are stunned.
Stunned to silence or boredom, one of the two, right? Well, cool. So the only other thing I wanted to say, yeah, 8.0.NET data services. So I'm going to say there's a lot of bashing that goes on for like WCF RIA and this and that, but boy, did it make life easy to stand up prototypes, to get projects kickstarted. We all know that there were those complex edge cases that we had to go and do some different things to make sure they're optimized. But I'm going to argue that the query provider on Entity Framework Core, especially with 5 coming out, has gone through enough iterations that a lot of the edge cases that were complex are now supported out of the box. That doesn't mean every query. You still have Cartesian product, issues, and you have to be mindful of how you build them. But we've got this new feature called Split Query that actually scans the query pipeline and optimizes what could actually be executed on the SQL versus the client side and splits the query so that some of it's evaluated locally. So it's pretty cool. But the announcement I want to make is more of a request, I guess, is if you go to github.net efcore. So GitHub, let me zoom in here. GitHub.net efcore. That is the Entity Framework Core source. It is an open source project. Everything we do is available there. So if you want to see how it actually turns a link into SQL, you can dig into the source code and see that. But if you go into the issues, there's a pinned issue. We have weekly status updates. We have feedback here. We do a bi-weekly show where we bring guests on and talk about data-related topics. It's not just Entity Framework Core. The team focuses on data in general. But we've got a survey here. And for those of you who do use EF Core, who have used it in the past, whether it's positive or negative or anything in between, thank you, Jim, for posting that to chat. We're planning our 6.0 release. 5.0 is going to come out in 2 weeks, .NET Conf. Hope everyone's there. I'll be talking about Entity Framework Core 5, as well as our .NET for Apache Spark, which is big data using C#. We just released 1.0. So those will be there, but we will release that. We're planning version 6, and we want to plan it not based on what we think is cool to work on or what we think people need. We want feedback from you and the customers you work with, and understand your pain points so that we can prioritize that planning, because we're going to be jumping into it pretty quickly. So we will evaluate those results, and it will feed into and influence the priorities in the way that we tackle our version 6, which will be the most confusing version ever, because we have an EF6 and now we'll have an EF Core 6. But then after that, we're out of the woods. So thank you, everyone. Appreciate your time, your attention, your questions, your feedback, and hopefully we'll be back to do this sometime again soon. I know the last time we got to do this in a conference room, I think at Sanctuary, wasn't it, Ken? Or
I think it may have
well, no,
actually
not
been at the new
Sanctuary,
place. Yeah.
Avalon. Yeah.
Yep. Yeah, you're going way back when you go back to Sanctuary.
Yeah, Sanctuary was a little bit farther.
Yeah. Great presentation, man. It was awesome. We've got a couple of JetBrains licenses to give away this evening again from our sponsors there. So I have rolled the dice, and we have Jeff Jones and Marco Costa. You have each won a license for JetBrains. It's a 1-year subscription to one product of your choice that they have, which is pretty awesome. And all you got to do is drop me an email, and I'm going to put my email here in the chat. And it's kenross@microsoft.com. So if you just drop me an email, Jeff Jones and Marco Costa, I will get you those licenses. And yes, I know we could all use if I could get the brain refreshed once a year, that's where the subscription is handy. All right, everybody. Well, thanks for coming out tonight. And we'll be doing this again next month. I've got to get the schedule finalized and pushed up, but it'll be the last Monday of the month as usual, which I guess means the 30th. So see y'all then.
See you, everyone. Thanks again.
Thanks again, Jeremy.
Thank you so much.
Bye.